Welcome to the 22nd lecture of this Predictive Analytics Regression and Classification course. Today, I'm going to talk about why we want to use Julia along with R or Python. So some of you have asked me question that R and Python, these are the two go-to language when we have to do data science. And I agree that even a year back, I was mostly a R person, but at the same time, I also delivered commercial project using Python. Of course, I delivered many commercial projects using R. But recently, about a year back, one of my senior colleague, Mr. Ajay Shah, he kind of encouraged me to explore this new language called Julia. So I decided, let me explore, and I was quite impressed with this new language called Julia. It is mainly designed for doing scientific computation. So in this video, I will try to argue that why eventually the data science community should adopt Julia as go-to language over R or Python. I'm not saying that you completely switch to Julia overnight. Yeah, if you have a project going on with R and Python, please do so. But at the same time, learn Julia, gradually move to Julia. And I will argue why Julia is giving us something which is extremely important to consider for any data scientist. So typical, if you see any mathematical equation that we want to write and we want to code, there is a big gap in our understanding. So if you see in this panel, in the left panel, this is essentially the three basic equation for Bayesian regression with a simple normal or Gaussian prior, where I'm assuming that this is my likelihood model, these are the prior model on the sigma, and this is the Gaussian prior on the coefficient beta. So this is a simple regression model. And now if I have to implement this model, say in R, this will be the code. It is the same R code. It is the code which is written by me. There are some functions also there where you can call these functions and do that. But what the point I'm trying to make here is the way we write our mathematical equation and way we code them in our programming language R and Python, many things get lost in translation. And as things get lost in translation, it reduces transparency within organization, within division, even within same peer group. Often a fellow data scientists do not understand what are we doing. If you write a program, in R or in Python and you share it with your friends, I can guarantee that your friends will stumble upon many lines that she or he will have trouble to understanding the code. Similarly, if you receive a code from your friend, you will stumble upon and you will be not able to understand many lines of code what she or he did. So that's and it takes a lot of time to understand exactly what is going on, and that contributes to something called lack of explainability in AI/ML and data science. So I'll try to make a limited point here. So what is lack of explainability in AI/ML and data science? So nowadays, many of the deep learning neural network model, they are so complex and complicated. Many things are not very easily explainable to common people, and or even scientists who are not trained as data scientist or computer scientist or statistician, for them also these deep learning neural network model is like almost like a black box. So these are the major criticism of AI/ML models in, and they call it lack of explainability. The limited point I'm trying to make here is the way we write our code that also contribute to lack of ML explainability in ML machine learning and data science projects. So here comes Julia that gives us an interesting part. Now here you can see this is a small code snippet from my Jupyter notebook. The way we write code, our equation in Julia, we can write our code exactly the same way. So this is a very, very important and interesting way we can write Julia code. Julia is a very high level language, so that makes the Julia very attractive. The expressivity, the way you express, the way I write my mathematical equation on the board, on my question, or on my notebook, I can write my program almost like SEM, and that program runs and give me the answer, and it's correct answer. That's a beautiful, I think it's a big leap forward for the way we do our data science project. So that is the main reason I'm very excited about Julia in data science. So this expressivity makes Julia a high level language. Now there is a big performance trade-off. So what is this performance trade-off? We know that C, Fortran, Java, these are high performance but low level language. So you have to be really expert. It is difficult to get an expert who is very good in C, Fortran or Java programming at the same time who is a very good data scientist. So data scientists, most of the time data scientists go to languages R, Python, MATLAB, SAS, Stata. These are the high level language. But what happened is they sacrifice performance. So these high level languages suffer from what is called two language problem. So Julia does not suffer from two language problem because Julia's compiler is written in Julia itself. So our Python, MATLAB, their compiler are written in typically C, in C or C++, mostly in C. Now, what happened in these high-level languages, that if you really want to speed up your programming, so that makes this R, Python, MATLAB what is called something called interpretable language. So whatever you are writing it, eventually the compiler of these languages are in C or C++. So that makes it very slow. That makes the R, Python, MATLAB languages comparatively slow. MATLAB is much better designed programming language, but overall they are not as fast as C or Fortran. So if you really want to write a program in MATLAB very fast, then what you have to do, you have to write the core program in C or Fortran, and then you have to call that C or Fortran function in MATLAB or Python or R using C call or Fortran call or F call. So but Julia does not suffer from two language problem because Julia is not a interpretable language. Julia is a compiler level language. So why Julia is fast? So essentially Julia's compiler was written based on 6 major foundational structure of major goal. The compiler tries to achieve 6 major goal. One is just-in-time compilation. So it compiles the code on the fly and optimize it based on the data type. So if you if you have a data type, say float 64, or if you have an int 32, or if you have something else, so it based on the data types, it runs the compilation, code compilation, and try to optimize its time in accordingly. Another one of the beautiful feature of Julia is multiple dispatch. So it determines appropriate method to call function based on argument type. So what happens is typically if you have an argument which has a different operation based on the argument type. So if the argument is string, it will do some kind of operations, and if the argument is float, then it will do certain other kind of operations. So what you will do, you will write a function saying if argument is this, you do this, if argument is that, else you do this. Now in the Julia, you don't do that. In Julia, you write a function where you declare argument is string, and similarly you write this another function with the same exact name, but you say that the argument is float. So now you have the two function with the exact same name, but the argument type is different, and that makes Julia maintaining the so it might happen that suppose you have an argument a, and a can have two kind of possible input. One is say that it could be a string, then it will do certain operation, and it could be float, it will do another kind of operation. Now you write a function where you say function name, say ABC function, the argument is a string, it will do certain operation. And then you write another function, exact same name ABC, but a is now float. So both function will be defined and perfectly fine, and Julia will just identify them based on their argument type, call that function, and bang. But if then else, you don't have to do the if then else. So what is the advantage of this? That you may have a string when the a is string, certain operations may not working or something, but still float is working. So that your project will not get stalled. Only that part of the problem of the project will have a problem, but the rest of the project will be still up and running. So this is a beautiful feature I found. And Python also have this feature, but Python you have to install a package called multiple dispatch, and then Python will allow you to do multiple dispatch. It doesn't come as a base package. R, I have not seen any package in R which allows multiple dispatch. So it's a beautiful thing, and it actually makes your implementation very dynamic. It makes your implementation very easy going and all these things. So another third is dynamic typing. It allows flexibility and ease of use, but it also allows compiler to optimize the code. Low level access to hardware such as SIMD instruction to speed up, built-in parallelization, allow computation to split across the core. So if there is any free core available, Julia figures it out and it can go and try to use that code. Efficient memory management, and uses the garbage collector to manage memory and allows explicit memory management. Now if you see the evolution of the data science languages, the first major data science language was SAS, that came in 1976. Its compiler was C. MATLAB was 1984. C, C++, Stata was 85. C, Python, C++, some other paradigm was also taken. R was definitely C++, and the last was 2000. When I'm talking about version 1.0 release, the actual may have started a little earlier. Julia's version 1.0 release was 2018, and the compiler was Julia itself. So that makes it Julia very fast, probably as fast as other languages. So here is a comparison that I have taken directly from Julia's website. So what they have done, they have taken some very nasty mathematical computation like iteration pi sum, matrix multiplication, matrix statistics, parse integers, print to file. It's a very complicated high complexity problem computation. Recursion, Fibonacci recursion is extremely difficult. You need a dynamic programming to solve it. Recursion, quicksort, use function, Mandelbrot. And if you do that, where C is being kind of created as a base, so all programs are being kind of put into 10 to the power 0, which is 1. And with respect to that, Julia, in fact, Mandelbrot, Julia is even faster than C, and rest of them are somewhat incomparable. Lula, Chit, and Rust are also similarly comparable. Go is a new language by Google that is also very fast and comparable. Fortran and in the same space. But if you see R and so R, all these things are, with respect to R, Julia were 10 times faster. And with respect to Python also, on an average, Julia was 10 times faster. So that's a beautiful feature that Julia is proposing, that on an average, if we can make sure that Julia, our data science projects implemented in R or Python are maybe on an average 10 times faster, or even 5 times faster than R or Python. Our Julia project are 5 times faster than R or Python, or 10 times faster than R or Python. Then I think it gives a huge advantage over R and Python. So R, Python, or even MATLAB. So I have compared here. I presented a comparison between Python and Julia, between different packages. For example, if you have the linear algebra operations, if you want to do linear algebra operations, you need to have a NumPy package. But Julia supports all the built-in, and the time performance, Julia is superior. Scientific library, SciPy, Julia SciML ecosystem is definitely far superior. Data science packages like Pandas, Julia's data frame and TS frame has superior data manipulation capability, and TS frame is being developed by our group, by Chirag and Ajay and Ayush. I'll tell about them later. There is a machine learning package, bunch of Python packages are scikit-learn, PyCaret, Light GBM, and comparable Julia packages are there: MLJ, Lighthouse, XGBoost. The Python, PyTorch, TensorFlow, Keras, Theano, they are still much better when it comes to deep learning packages. And Julia has Flux, Transformer, and Lux, and they're trying to catch up. I would say if you currently have a project which is a deep learning project, I will recommend still you stick with your Python thing, because Julia maybe is trying to catch up, which is but I am pretty confident in next 3 to 5 years time, Julia packages will be if not better, then at least at par with the Python. If you want to implement operation research projects like optimization things, like PyOmo is the kind of Python package, but Jump is the best. I think in Julia, Jump is far superior than PyOmo. If you want dashboard UI, like Dash and Genie, both are equivalent, I would say. Dash is the Python UIs and dashboard. 3D graphics, Maki is beautiful, compared almost like no Python is as good as Maki. GPU compiler, if you do PyCUDA, like, CUDA, OpenAI, so all these Julia providers, like API, NVIDIA, Intel, AMD, Apple GPUs, on this Julia provide the same API, but Julia is superior due to its native compiler. Even in the GPU compiler, Julia compilers does better than PyCUDA. So in Python's Julia SciML, what Python has done, that for all the Python functions like scipy dot whatever you want, you have a corresponding Julia things that are named in there, and if you click on that, it will directly take you there in that function. So you can just have those functions there. So similarly, C++, Fortran, MATLAB, everything. And now some of the notable uses of Julia, like Amazon, Apple, AstraZeneca, Capital One, IBM, Intel, JP Morgan, Microsoft, Moderna, Pfizer, these all companies are now gradually moving their data science project to Julia. It's not like they're doing over time. Of course, that nobody will do that. I mean, they will run their mission critical projects still in R and Python. They don't want to disturb that. But any project that is starting from the scratch, they are definitely considering Julia as a serious options. Among the other major organizations, NASA, US Fed Reserve, Brazilian Space Agency, for sure they're using Julia. Among the major universities, MIT, Stanford, UC Berkeley, they are all offering their linear algebra and other different courses in Julia. So far, worldwide 1 million plus users, used by biggest companies in US such as Moderna, JP Morgan, AstraZeneca, Pfizer. Moderna used Julia for vaccine FDA approval and taught at MIT. It is being taught at MIT. So many companies are trying to replace the R, SAS, MATLAB, many other aging platforms. And Julia Hub is working with Infosys nowadays for an airline industry, routing optimization problems and other problems. It was confirmed by Dr. Viral Shah, who is the co-creator of Julia and CEO of Julia Hub. So now I will speak about the CRRao package that we are in CMI. We are developing this single API for diverse statistical models at Dr. F.C. Kohli Center at CMI. We are building a package called CRRao in Julia. It was funded by MIT, and version 0.1.0 was released in last December. So for example, if you want to develop an empty cars, you want to just fit in this predictive analytics model regression classification course, we want to fit, say, miles per gallon as equal to beta naught plus beta 1 horsepower plus beta 2 weight plus epsilon. Now in this model, this is how you will implement in R, and in Julia all you have to do, just call, like, instead of LM you just call fit, and then at the rate of formula, the exact way you have given it in R, exact way you give it in the Julia, then the data frame, and then you have to say linear regression. That's it. And when if it is logistic regression, then you say logistic regression. If it is Poisson regression, right, say Poisson regression. Because of the multiple dispatch, still fit will there. So for each fit, all you have to do fit. That's it. Similarly, so, and then what we did, we compared the exact same model, exact same implementation in Python, R, and Julia. And what we found that in Python sklearn, it took about 560 microseconds, milliseconds actually, and in R it took about 380 milliseconds, and in Julia it took about 160 milliseconds. So what is it going on here? So what we found and this is a really interesting phenomena that I found, and that makes me super excited, and why I will tell you. In industry nowadays, what is happening is nobody wants to maintain their server, so they are moving all their data related work and data science related project in the cloud. Now in cloud, all cloud services are basically charging their client for the services, the time they are using their services. Now imagine you have a service that for each microsecond it charges the $1, right? So the same model, this is the exact same model. For the exact same model, when I'm trying to fit in Python, it will cost me $560, whereas in R it will cost me $380, whereas in Julia CRRao will cost you only $160. So immediately you can see Julia makes it economically viable. You can save a lot of money. You can reduce your data science project cost significantly if you just move your project gradually from R to Python. That will reduce your implementation cost significantly, at least for 30, 40, 50%. Now, once you reduce your economically the implementation cost, that makes the profitability and return on investment on the data science team and data science project more viable. At the same time, the data science projects become a much more sustainable language, because if you are implementing the same model at a 1/2 of a time, that means not only you paying less for your model implementation, model training, essentially you are consuming less energy. That means your electricity cost is going down. That means your carbon footprint to train your model is going down. So that makes Julia is a go-to language, and this will help all the Indian companies, Indian corporates, to compliant with their ESG requirement. What is ESG? ESG is environment and sustainability and governance. It's a very important concept that is becoming very popular, and most of the companies in India, in Europe, in US, they are trying to become ESG compliant. So Julia will help the Indian industries to become ESG compliant. So in CRRao, you can implement this, simple linear regression and the Bayesian linear regression. As you see, the exact same model, exact same DF, you get linear regression, and at the end, if you just give prior reach, it will just go and implement the Bayesian linear regression, and it will itself figure out. If you don't give anything by default, it will implement OLS method. But if you give prior reach, it will implement quantum Monte Carlo method. It will figure out, okay, the user is asking for me to implement Bayesian linear regression, and it will just go and implement the same. So here I have given you a code. So this is the Stan code that I have written for Bayesian regression in R. It's about 30 lines of code that I wrote in Stan, but and then I thought I can write a small line of code which will be like in one line implement the Bayesian linear regression with reach prior. But what I found that implementing anything on the top of Stan is very difficult, because Stan makes it a 3-language problem, because you have to have a very correct version of C in your system, then you have to have a correct version of Stan, and you have to have a correct version of R, and then only you will be able to make anything on the top of it. So 3-language problem is even too much to handle, so I just kind of gave up on that idea. But when I found Julia, I found that, okay, yes, I can build something very easy. And here is Bayesian regression with rich prior implementation with Julia. So currently CRRao implements linear regression, logistic regression, Poisson regression, negative binomial regression. It can implement frequentist method, Bayesian method, both OLS and Fisher scoring method, MCMC, and Hamiltonian Monte Carlo method. Currently, we are trying to implement discriminant analysis, survival analysis, bootstrap inference. Bootstrap inference is almost 50% done. It will be released soon. Hierarchical Bayesian models, Gaussian process regression, mixed effect models. These are all we are trying to implement by the next year. And this development is completely open development on GitHub. And all the issues that we want to implement, there are a bunch of good first issues that I have kind of marked it. So anybody who are interested contributing in this project, please do so. You can pick up any of your first good first issues and start, developing in either you can start with comment, and you can write a small piece of code and submit it in, do a pull request, or just put a, thing. And then there is if you really like our project, CRRao project, you can, here is the star, you can, click the star and support us. So more on Julia packages. Our group is developing a few more packages, TS frames, nighttime lights. So nighttime lights is a package which handles the satellite, which tries to do data science on satellite images. So in the satellite images, there is a particular brand which captures the images of the nighttime lights, and it's do the data science on the nighttime lights. So this package is a very beautiful package. Then survey and CRRao. So these are the packages that we are building. Our GitHub stars are right now around 130, but I am hoping that soon it will go up. Please support us. Click the star button and support us on GitHub. Our mentor, Dr. Viral Shah, who is a co-creator of Julia, and Professor Alan Edelman, distinguished professor of MIT. And then our team, Siddhant is a CMI student. Shavik is also CMI student, BSc student. They are consistently contributing in this package. Mausam is my friends and collaborator for a long time. Ayush is in now Australia, Susan, Ajay in Bombay, and Chirag in Delhi. Chirag is one of the major implementer of TS Frame. And this is you can see there is a team, this team is all over the country. And thank you very much. And please do support us on the GitHub. I will share the link on the GitHub below in the YouTube description. Please do support us and click us and come and join our group to develop CRRao package in Julia, adopt Julia. I am sure in next 3 to 5 years down the line, Julia will become a go-to language for everybody. Thank you very much. See you in the next video.